Okay, so in review question 4, again it's referring to the same prior process. Here I just updated the slides to say that the gas is a monatomic ideal gas and it is in a sealed container, and it's taken through these two different processes or paths in the PV diagram. And we're asked, is the absolute value of the heat exchange with the gas for path A greater or less than or equal to that for path B? So we're asked to compare heat exchanged for both processes, so we got to think about the first law of thermodynamics that tells us that delta E thermal is equal to work on plus Q. Okay. So the delta E thermal for a sealed container, I don't even have to, I guess I'll just write it down. So delta ETH is equal to 3/2 N or delta T for a monatomic gas. So, and since if the container is sealed, N and R are constants, and in the prior question we determined that the change in the temperature for path A was, in a sense, at least the initial temperature and the final temperature is the same, and for path A the temperature of the gas always remains the same. For path B, the temperature does change along the path, but its initial and final temperatures are the same. So TFB is equal to TIB, because P final is V final over N, or for process B is equal to P initial V initial over N or for process B. So that is by definition the temperature. So they have the same initial, and both processes start in the same state and end in the same state, so it's probably overkill here. But hopefully I want to just show you the state here that the delta E thermal for process A is equal to the delta E thermal process B, and both are equal to 0. So for the entire processes, there's no change in the thermal energy. So they start at the same temperature, end at the same temperature. So in that particular case, I know that the work on is equal to negative Q, or that Q equals negative work on. Okay. Now the work, we can figure that out from the area underneath the curve. So the work on is proportional, or in a sense, actually not just proportional, it's equal to technically the area under the PV curve. So it's work on is technically the negative of the area under the PV curve, but the absolute, since we're comparing absolute values, I just need to compare areas here. So in both cases they are compressive. They're compressive processes. So I'm going to write that. Switch up colors here. So separate work here. So in both processes, work on is positive, since V final is less than V initial, so we're going from 5V to V, so the outside environment is doing positive work on the gas, which means the absolute value of the heat exchange would be negative, but we're comparing here. But again, the work on is equal to the negative area under the curve, so I know that the absolute value of the work on in process A is less than the absolute value of the work on in process B, since the area underneath the curve for process A is significantly smaller than the area underneath the curve for process B. And let me try to think here. That means since the absolute value of the work on is equal to, so work on is equal to the absolute value of Q in both cases, because the delta E thermal is 0, that's coming from that conclusion, then I can state that the heat exchanged in process A, the absolute value, it's negative and is less. It's also negative in B, but comparing the absolute values, there's a smaller amount of heat exchange released, in a sense, or removed from the gas in process A, and the amount of heat released or removed in process B. So the correct answer should be less than